Okay. I guess this can be broken. We will continue on the chapter 10. We will finish by this week. Hope. Um, okay, let me explain this elementary row operations. Okay, let me just review and make one example on how to use the elementary row operations. Okay. So first, let's say we have a system of equations. Okay. Let's say this is our system. Okay. And we need to solve the system and find a solution for x, y, and z. First, what we are going to do is we are going to have augmented matrix. Okay, let me write here. Augmented matrix. So we have 1, 1, 3, negative 1, 2, negative 1, 3, negative 2, 5, and then 4, and 14. And this is our matrix. Okay. So the left part here will be correspond to the x, this will be correspond to the y, this will be to z, and this will be correspond to the constant. Okay. Okay. Now the next thing here is we are going to make the row. Let's say we have a row 1, row 2, row 3, and the idea is to make the row becomes this point here becomes 0, and this become 1, this become 1. Okay, so that's our goal. So our goal will be resulting that this augmented matrix will be, yeah, at least this. Okay, at least this, and this will be the number here. So we are going to do some efforts. Okay, we are going to do some efforts to make this uh, right side of this augmented matrix happens. Okay, now doing that efforts, it needs some operations, some math operations. Okay, so we can do every math operations, like we can multiply this row with the constant, like we can multiply with 3. We can each row, we can subtract each other. We can add, we can subtract. Okay, we can multiply with the constant. Like for example, in our case, we are going to see this 1 and 1 here is same constant. Right? So let's try to subtract this two. Uh, let's just write the first one, still the same R1. Okay, because I'm going to have the second one as 0, so I will write right here. This is R1. The second one is R2 minus R1. So 1 minus 1 is 0. 2 minus 1, 2 minus minus 1 is 3. Okay. And minus 2 minus 3 is minus 5. And minus 4 is 6. Okay, this is my second row. Okay. Now the third row, it has constant 3 at the first section. I need to make this 0. So I need to subtract uh, either triple R1 or triple R2. Let's take the 3R1. let's say 3R1 minus R3, or you can write R3 minus 3R1. It will be the same conclusion at the end. So you can have many methods at the process, but the answer should be the same. It should be the same. Okay. So 3R1, so multiply with 3. This will be, let me write with different color. This is 3 minus 3, 9, and 12. Okay. So 3R1 minus 3. So 3 minus 3 is 0. Okay. Minus 3 minus minus 1. So minus 3 plus 1. Uh, I think, because we have 14, I think better is R3 minus R1. Because I don't like to have a lot of negatives. So let's try this one. So 3 minus 3 is 0. Minus 1. Minus 1 here. Minus 3. So minus 1 plus 3. Minus 1 plus 3 is 2. 5 minus 9 is minus 4. Okay. 14 minus 12 is 2. I think this will be the better choice for me. Because I like this one. Okay. And then what else we can do? We need to make this one to be 0, right? Okay. The only way to do that is, I think, to add or subtract with this, and maybe multiply with some number. But I think because it has 2, negative 4, and 2, we can divide all with the same constant. Let's say we can divide by half. Okay, let me write that. Okay, let me write this become 1, negative 2, and 1. So this will be still same 1, 2, half R3. Okay. To make sure to confirm, okay, what this is, the R1, R2, R3. This is not the same as the one that we are using at the beginning. This one is the one that previous process. Okay, R1 means that this is the same as the previous one. R2 means the same as this one. Okay, this is the previous process. And R3 here, it becomes half. So half of the process of the previous process. But so it will be 1, negative 2, and 1. So we can compute this, and maybe we can multiply with 3, this part, and we can compute R2 and R3, okay? And uh, to make one of this section 0. So let's just do that. 1, R2, and this will be R2 minus 3R3. It will be 1, 1, 3, 4, 0, 3, 5, 6. So R2 minus 3R3 will be 0. 3 minus 3 is 0. Minus 6. Minus 6. Oh, minus 5. Minus 5 plus 6 is 1. And 6 minus 3 is 3. Okay, so we will have oh wait. Uh, I think to let you know, okay. Let's say sorry. Okay, we are going to solve the R2 to become a new R2 uh, minus 3 R3. Okay, so this will be R2 is 0, 0. 3 minus 3 is 0, minus 5 plus 6 is 1, and 6 minus 3 is 3, and then the other one is still the same, R3. And let me explain one more. So 0, 1, 3, 1, and then we can switch this row 1, row 2, and row 3. We can switch. So that we will have this augmented matrix. So this one is z, so z is 3, and then 1 minus 2, 3 is 1, so this will be y. Y is 7, and x is x minus 7 plus 3, 3 is 4, so x is okay. Let me explain from the beginning. Okay? So I forgot to mention something. Okay, so augmented matrix. So this is a form that is from the questions. Okay, let me start from here. Let me explain one more. So x minus y plus 3z 4. This is the R1. X plus 2y minus 2z is equal to 10. Is this the R2? 3x minus 1 plus 5z equal 14 is R3. Okay, now we have this R1, R2, R3. Now we are going to write in the augmented matrix. Okay. Okay. Now to solve this, okay, let me explain one more time. We need to make the form becomes 1, 1, 1 like this, and then 0, 0, 0. So the left bottom will be 0, 0, 0. Okay, so this would be 0, 0, 0. So that's our goal. Okay, and how to do that? I forget to mention something. So uh, every row we can replace with a new row, okay, with some mathematical formula. Okay. For example, this one here, I replaced the row 2. Okay. This new, this, let me write here R1, R2, R2. This is the new row, R1, R2, R2. The R2, row 2, is from previous step, we are going to have R2 minus R1. So R2, okay, that's our R2, this one, okay, minus the row 1. Okay. So we can replace the row that we are going to replace. For example, this R2, we are going to have like R2, we can plus, we can minus with any row. We can plus minus R1 or plus minus R3, and we can also multiply R2 and then plus minus and then multiply with other constant. This is we can do, okay? But the goal is to make this 0, 0, 0. So I think we can have several ways to doing that. Okay. First is maybe let me do it here. Let's erase this. First is we can minus R1. Okay. So R2 minus R1. Of course, this will be 1 and 1. It's subtracted and becomes 0. Okay. And we can also subtract with the R3, but R2 needs to be multiplied with 3. So 3R2 minus R3. This is also can be done, and we can solve that. And what else we can do? Um, oh, we can also, if you look here, we can also we can multiply this two. So make it the 0, and then if we switch the R1, R2, and R3, so we can plus the R3 half half R2 plus R3, or R2 plus 2R3. How this replacement need to have the R2 here. They need this R2 need to be right first, okay, as the subject, okay, as the subject, as um, the subtraction or the addition one. The R2 is going to be the subject, okay. And if we look at the R3, we can have two choices, okay, at least for making this 3 0, or this one, we can subtract with R2 or R1. Okay? So here we have, at the example here, the R3 is R3 minus 3R1. We can also have R3 minus 3R2 if we want. Okay? And you can also check. And I'm recommending you to check the other way, the other solutions, not solutions, the other method. Like for example, you try this one, try this one, or try this one, and try to solve and making the goal that the left bottom here is 0, 0, and 0. Okay. Okay. We can have R3 minus 3R1 or minus 3R2, okay, to make it the bottom one is 0. Okay, and then like you see here, we can multiply with the constant, we can divide by constant, we can multiply by constant, as long as we are going to find our goal. Okay. In the same way, this one, and we can switch the positions. We can switch in any positions we want. Okay. From the beginning, we write our augmented matrix. We can switch on early on. Okay? But for what? Right? So we are going to see at our process here. Usually we are switching our row when we are looking at this. If we have the 0, 0, and then 0, 1. Okay, I think better to have this one is at the bottom, right? Because we want to have 0, 0, 0, and 1. Okay. Now, let me write some notes for you. Some notes and maybe giving you more example. Okay, a matrix is in row echelon form if it is satisfying following conditions. Okay. The first non-zero number in each row is what? This is called leading entry. The leading entry in each row is to the right of the leading entry in the row immediately above. I will say later what this means. All rows consisting entirely of zeros are at the bottom of matrix. For a matrix is in reduced row echelon for if it is in row echelon form and satisfy that every number above and below each leading entry is 0. For example, if I have a random augmented matrix that is already in middle part of process of echelon form, let's say we have this, we have a lot of this. If you look here, I will one, 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 and compare with the another augmented matrix that we have here. 1, 3, 6, 0. If you look here, this is 1, 1, 1. This form here is row echelon form. The form, in the form. We are looking at form. If you look here, going one from here, going to here, going to here. It's not in row echelon. One way to solve this is we need to switch. Okay? Switch this to here, and maybe switch on this to. And if we solve this to be 0, 0, 0, 0, okay, we are going to have the reduce row echelon form. So row echelon form is when we have 1, 1, 1 here, and then 0 at the left bottom. Okay. I think let me just take some pic- transfer to screen. Okay, this is what we are already been doing before. Okay? So idea is, okay, we can start from the top, okay, obtaining 1 in the top left corner, and obtain zeros below that. Okay? So we are going to have this 1, okay, if you look here, and then every 0 is we will have here below that 1. And then start the other one, taking this into this one here, and making the bottom of one is the 0. Oh, okay, sorry. Okay, wait. Okay, now let me explain one more. So we start by obtaining 1 in the top left corner and obtaining zeros below that 1. Okay? So let me show you here, okay, in this 3 4 matrix. So obtaining first 1 here, and then obtaining 0 and 0 below that one. Okay. Next step is obtaining 1 here and obtaining 0 here, and then obtaining 1 here at the very end. And I think for 3 4 matrix is simple enough that you will get the solution for x, y, and z. You can have this, and I think from here you already get simplified equations, and you can directly show that this z is equal something, and then this y plus something z equals something for the second one here, the second row, and the first row you can have x plus something y something z equals something, right? And you can have this substitutions and then solve the solutions, and you can find x, y, z, right? Um, but you can also, okay, uh, thing about going to have taking sometimes to using the row echelon form, try to do some operations and make it this one 0 0 and 0. So you have 1 1 1 and 0 0 0, and this will directly getting to your x, y, and z. So x is, let's say this is a, b, c. So x is equal a, y equal b, z equal c. You can also do that. But if you want just to stop here, that's okay, and then you can just substitute to the um, uh, with the equations. We substitute z to the second equation and substitute x, substitute y and z to the first equation to get x. Okay, and then let me check. Okay, this is called the Gaussian elimination. Okay, the process we are taking on. So first, the idea is augmented matrix. Second is taking the form we call the row echelon form, the 1 1 1 we saw before, and then we are going to have a substitutions. Resolve x, y, and z, right? Or maybe more than that, because we can have more variables. We can have 4, 5, 6. Okay. Okay, I think I can give you one more example, maybe two, to get into the. Yeah, I think first is the just Gaussian elimination here, and then the other one is when we have this another 0 0 0 at the right top. Okay, let me give you the example. And I hope you can also try by yourself. Okay? So you know the example, you know the questions. You try by yourself. Try the Gaussian eliminations and see if you understand what it is about. Okay, let me write the questions. Solve the system. This is so. Okay, let me write the matrix. So 4, 8, 4, 4, and 3, 8, 5, so 2, 1, 12, 7. Okay, and this will be our augmented. Okay, first, based on what we have done before and what we have learned in row echelon form, the first thing is taking this form, taking into 1, right? So we need to divide all by 4. So taking that root makes this 1 over 4 1. Okay. And the rest will be the same. Let's start slowly. So 1, 4 divided by 4, 1, 2, 1, 3, 8, 5, 11. Next, we need to have this 3 and 2 is making it 0. Okay, and to take that 0. So we need to take sometimes to do some operation on R2 and R3, making them 0. The first uh, the first constant should be 0. Okay, so add new augmented matrix. If you look here, because the first one already one constant, we can subtract this, or we can subtract this to make it this R2 and R3 0, right? At the first constant here is 0. Okay, so the first one, let me just write 1, 2, negative 1, 1. This is the just R1 from the previous R1. Okay, and R2 becomes R2 minus 3 R1, because I want to take this 3 minus triple 1. And let's say we are going to multiply this with 3, 6, negative 3, and 3. Okay, this is just my calculation here. Okay, not really in the matrix. Okay, that's this green one. So R2 minus 3 R1, 3 minus 3 is 0, 8 minus 6 is 2, and 5 minus 3, so 5 plus 3 is 8, and negative 11, negative 3 is negative 14. Okay. Okay, the other one, I will take the root of I think, oh, sorry. This should be negative. Okay, negative. Okay, sorry. So I think we can add. Okay, we can add R2 and R1. So we can add R3 plus 2R1. Okay. Sorry, I'll leave the negative out. Okay. Use light blue to take this with multiplication of 2. This is 4. This is negative 2. This is 2. Okay, so negative 2 plus 2 is 0. 1 plus 4 is 5. 12 minus 2 is 10. Negative 17 plus 2 is negative 15. Okay, again, we are going to look at our matrix here, and what we are going to do, we need to have these two become 1 and this become 0, right? So the first process is just to divide by 2. Okay, we need to make it 1. So let me just write again. 1, 2, negative 1. I'm doing all the process one by one, but in your paper or in your calculation in your mind, if you like, and you can do some multiple process altogether, you can do that also as well. So for example, the first one here, I'm writing that, oh, I need to define R1 by 4. If you want to do that and directly taking this second and third row to into into one process, that is possible. So it really possible. So you can do that like this one. So from here you can take the new R2. So new R2 is R2 minus 3 R1 4, like that. And the R3, if you like to combine these two process, is R3 plus 2 R1 divided by 4. Okay. This is, I'm just going to show you one by one the process, okay, inside the whole equations. But in your calculations, if you want to do faster and you can take some calculation in your mind, you can combine them all and just be careful. Okay, just be careful. But you can do that, okay, if you like and you want to calculate faster. Okay. 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 We are going to have this R1, and the second row we are going to divide by 2. So this will be 0, 1, 2, and negative. So let me just write here one by one. Okay. And taking some time to make it is 5, 0. So what we are going to do is we are going to subtract, right? We are going to subtract with this R2. So 1, 2, negative 1, 1. This is the same. And we're going to change the R3. So R3 minus 2R2. Okay. Okay, 5, sorry. 1, 2. So 0, 5. Let me check this. So this is multiplied by 5. Then 5 is 35, negative 35. Okay. So 0, 5 minus 5 is 0. 10, oh, this is wrong. Sorry. It's divided by 2. It should be 4. Okay. Okay. So it should be 20. Okay. And 10 minus 20 is negative 10. And negative 15 plus 35 is 20. And now this is our root method here. Okay, what's next? Next is we want to have this one equal 1, right? So we can just divide by negative 10. So this will be 1. Divided by 10, negative 10, minus with negative 2. Okay. This is R3 divided by negative 10. And now we have exactly 1, 1, 1 here and 0, 0, 0 here. And we can do substitutions. Okay. Then do some substitutions. So that z is negative 2. 1 plus 2, negative 2 is negative 7. This one is y, sorry. Y. Okay, so y is 3, right? Oh, sorry. 4. This is 4, sorry. So 4, 1. Okay. And x plus 2, 1 minus 2 is 1. So x is, so 2 plus 2, 4, going to the right side is become negative 3. So if you solve, you can write negative 3, 1, and negative 2. Okay, let me rewrite this in the new slides. Okay, and let's see if we can do some further calculations with the, we call the Gaussian, Uh, so we have this is we call this is Gaussian elimination. The other one is Gauss-Jordan elimination. Okay, first from here, is there any questions? QR code. Here. Okay, so for those of you who are coming late, is scan. Okay, I think that should be enough then for you. Scan. Okay, now yes, Scarlett, that should be correct. Like from this one here, I will show you that we can have many ways to solve. Okay. Like the one that we are going to have here, as long as all your calculation is correct, like the plus, the minus, sometimes that will be the mistake that you are making. As long as the calculation is correct, the solution should be also correct, the same results. If we check here, I think there will be, for example, if you want to try something aside from the steps here, because what I'll show here is the efficient way in this particular system. But if you are having some exercise, then you need to choose which one is effective for the problem. Uh, Sometimes the mistake in this row echelon form, aside from the calculation mistake or the science mistake, the negative and plus, is when we are going to have here, you are not really solving coming row echelon form, but you are making, for example, if you have this, this is already 0, 0, but you are making mistake that you are calculating this R3 or R2 with maybe R1, and maybe your result will be having one, and then you are getting one more this in this part here. Let's say this is another constant, and then you are trying to solve, and then you still have maybe getting one again in this part here. This should be 0, and getting another constant here. That means you choose a not really efficient way. Okay, maybe you are going cycling, not really having this form here. We need to go. We need to go to this root, like 0, 0, 0, and 1, 1 here, 1, 1, and 1 here, 1, 1, 1, and 0, 0, 0. Right? This part. But sometimes maybe we choose uh, wrong, not wrong, but maybe long run. It's a long run, and you are going a cycling, and maybe you will get at the end, but it takes time, and that's how sometimes you make mistake, because when you have a long calculations, the percentage on how you are going to find mistake is higher, right? If you have a long calculation. But if you have short calculations, effective calculations, your mistake will be reduced, I think. Okay, let me rewrite this part, the last part here, in the new slides here. Okay, 1, 2, 1, 1. Now the reduced row echelon form is making this, and this is 0. Okay. Let's try doing that. Okay. So let's see from some row 1. Okay. I think row 1, if we look at, let me use different color. If you look at this negative 1 here and 1 here, we can plus this 2 to make it 0 at least, okay, for the row 1. So row 1 will be plus 3. Okay, let's write that. So row 1 is 1 plus 0 is 0, 1, 2 plus 0 is 2. This will be 0, and this will be 1 plus negative 2 is negative 1. Okay, the second row, we can have some additions. Okay, if you look this 4 and negative 1, we need to have at least negative 1 multiplied by 4. So R2 or even, I think to make it safe, okay, that's wrong way that I told you before. If we are thinking this to plus with this, we are going to have 0 plus 1, and that will be the wrong way. Right? We have another 1 at the left that we don't want to. Right? So the idea to solve this is going here. So we have to subtract 4 with 1 multiplied by 4. Okay. So that's I think the better way. So R2 minus 4 R3. So R2, 0 minus 0 is 0. 1 minus 0 is 1. 4, let me write here, it's become 4 and negative 8. 4 minus 4 is 0. Negative 7, negative 8 plus 8, it's 1. And this will be the same. Okay. Okay. Now we still have this 2. We can multiply this or subtract this with this, right? And this we need to multiply by 2. Or yeah, so R1 multiply with the R2, or R1 subtracted. Okay, so subtracted. Let me write it again. So R1 minus 2 R2. This will be 2. Okay, so 1 minus 0 is 1. 2 minus 2 is 0. 0, 0. Minus 1 minus 2 is minus 3. And the rest will be the same. Okay, now we are going to have directly the answer. The z is equal negative 2, y is 1, and x is 3. Okay. And this is also called the Gauss-Jordan elimination. Okay. You can have this method also. It takes some time to make it 0, 0, 0. And it depends on you whether you want to take this method or keep the previous one. and take this just substitutions from this one. I believe because it's just a three simple a linear equation, three equations, right? And you are going to see here that I think we can just substitute easily. But if you have more variables, maybe 5, 6, 7, 8, I think if you want to do this, that will be really helpful. Okay, this 0, 0, 0. Okay. Okay. Type of solutions. Okay, so types of solutions. How many kinds of solution we have? Okay, it's similar to what we have done last week. I think I already explained some parts. You will have no solutions, one solutions, and many solutions. Right. So we are going to look at in the matrix form. So solutions of a linear system in row echelon form. Okay, I think I can just write the matrix 1, 0, 0. So this part says 0 equal 1. Okay. If this happens, we can conclude that this is no solution. This is just random equations. If you see here, that is, this is perfectly getting each variable for solutions. So each variable is a leading variable, which means the variable is this one, right? And you get exactly one solution for x, y, and z. Now the other one is the third row having all 0. And we say that z is not leading variable. And this will lead to infinitely many solutions. Okay. A system with no solutions, we call this is inconsistent. And infinitely many solution we usually call dependent, because it can be having many solution and it depends on for example the last one we are having another variable to visualize what it is. So which means dependent is we can take any real numbers and it will fit with all the possible equation in our row echelon form. So all real numbers will equalize all this solution. So the solution is really infinitely many. So yeah. Actually, if you want just trying to solve the uh, infinitely many, you still can solve that, but we can solve through another parameter. Let's say parameter t, so another variable. Let me show you in a brief. Okay, let me give you an example, especially on the infinitely many sources. So negative 3x, negative 5y plus 36z equal 10. And the second one is negative x plus 7z equal 5. The third one is x plus y negative 10z equal negative 4. First, we write this into our augmented matrix. Switch the third and first row. The third row has one. Okay. And what next is need to take this to 0. Okay. If 1 and 3 to become 0, we can take that with the first row, we can subtract or add. Let's do that. First one is just 1, 10. Okay. So this is R1, and R2 will be R2 plus R1, which is negative 1 plus 1 is 0. 0 plus 1 is 1. 7 negative is negative 3. And 5 is 1. 5 minus 4 is 4. And the third one is 3 plus 3R1. Okay. So 3R1 will be 3, 3, negative 13. Okay, negative 3 plus 3 is 0. Negative 5 plus 3 is negative 2. 36, negative 30 is 6. And then negative 12 is negative 2. Okay. And we can multiply this with 2, right, to take this out. And let's say we have 2R2 is, this is 2, 6, 2. 1, 1, that is 10, negative 4. Set this 0, 1, negative 3, 1. We want to have this 0, right? So this will be R1, R2, and R3 plus 2R2. So 0 plus 0 is 0, negative 2 plus 2 is 0, 6, negative 6 is 0, and this is happened. Okay. So you get this 0, 0, 0, 0. This leading to our infinite linear solution. But if you're going to look at what is really happening, we can see in the equations. Okay? So this means that okay, we still can solve this one. Okay, we still can solve this one. This minus. Okay, it will be 1 minus 1 is 0. This will be negative 7, and this will be negative 5. Or let me just write that in a way. This will be 0, 7, negative 5. And let me remind that this will be results from R1 minus R2. And if you look here, that is x minus 7y is equal to negative 5. And we have y minus 3z is equal 1. If we are going to solve this in terms of x and y, sorry, this is okay, this is in x and y. And if z is any t real number, then we can write x is 7t minus 5, y is 3t plus 1, and z is equal t. So we can just write the solution as 7t minus 5, 3t plus 1, and t. Okay. Where t is any real number, where t is any real number. And this will become a parametric, it will become a parametric equations. Okay, any questions? Any questions? Any question from here? Okay, so I hope you get the idea behind the process in this system of equations. There is some modeling on system of equation. I will just skip that for a while because I think modeling, as long as you understand the questions, I think it should be okay. Okay. We are going to the next section in our chapter 10. That is the algebra of matrix. So for the Gaussian and Gauss-Jordan elimination, probably I will give you some exercise to see whether you understand or you can solve it through the Gaussian elimination or not. Okay, maybe later I will attach on the Google Classroom. Okay, the next part here is the algebra. First is we call the equality of matrix or matrices for plural. We call matrix, let's say matrices A with some row and column. and B also with some row and column. They both equal if and only if they have the same dimension, row and column corresponding and corresponding entries are equal. That is for the row and the for example A, B, C, E. And based what we have, that is we can conclude that A is 1, B is 3, C is 5, D is 2. I think that's just easy, right? But if we have this, it seems that it's just rotating the matrix, but this is not it because the different row and column. Okay, so that is the equality of matrix. The other part of the algebra will be the sum, difference, and the scalar products of matrix. So let A So let's say we have A, B, they are matrices on the same dimension, row and column, and C is any real number. Okay. If we have A plus B, means that we can add these two matrices. So we are adding all the entry inside A and B. Okay, I think that should be not too difficult. If we have 1 minus the same way, and we have multiplied by some constant C, a scalar C, this is I think there will be no real problem here, not really a problem here. What really means is if your A is say 20735 half, and B is 10-3-1-2-2. So A plus B will be 2 plus 1, 3, 3, 3, 6, 9, and then -1, 2, and 3. not really a problem here, I think. Okay. But I think the one that is important is this one, property. Okay. The property, if we have A plus B, this will be the same as B plus A. A, B, C is matrices with n size. And okay, I need to. This is a capital A, capital B, capital C. Okay? There are another small c and d. This will be scalars. And we have A plus B plus C, capital C. This will be A plus B plus C. If you have small c, small d, and A, this will be multiplied same as C, B, and A. But if we have C plus D, the scalar, and then A, this means that we can also separate the A into this. And this will have another scalar C. This is also, we can put A and B into separate fractions. Okay, example. If you want this to ask or discuss, just write in the chat box and I will read the message. Okay, so solving. Okay. Okay. Now, if we have an example how to solve the solving the matrix equation. Let's say we have 2x minus a will be, and we know the a, for example, if a matrix A is this, and matrix B is this, then we can write 2x is B plus A, right? And we can say that x should be half of B plus A, right? And we can write now that x should be equal to half, and then write the matrix B for 1 and -1 and 3. And plus A is 2, 3, -5, 1. Six, 2, -4, 4. And this will be resolving 3, 1, -2, 2, and this will be the solution for x. I think that should be easy enough. I think I can make it soon. Okay. Now there is some uh, different thing when we are doing the multiplications. This is the multiplication of matrices. So let's say A, B is matrices. The product of AB uh, is defined only when the number of columns in A is equal to number of rows in B. Okay, so for example, A, B, this is matrix, this is matrices, this is dimensions. For example, if the dimensions of A is m and n, the B, the matrix B should be start with n and maybe still k. This still doable to take the multiplications. Okay. Let me write in the new page. Or maybe you want to write first. Wait for a few minutes. Okay, let me write if this is row A, okay, and this one is a column of B. Okay, then the inner product will be A1 B1 plus A2 B2 plus tails AN BN. For example, if you have 2, -1, 0, 4, and 5, 4, 3, half, this means that we will have 2 multiplied by 5 plus -1 and 4 plus 0 and -3 plus 4 and half. And this will be giving 10, -4, 0, plus 2. So 6 plus 2 is 8. This will be given 8 in the results. Okay, so by definitions, okay, by this definition, if matrix A is M and N matrix, row and column is M and N, and matrix B is N and K, then their product is M and K matrix. Here M and K. This is the product of A and B. So it will be C equal C, where the C is the inner product of the row A and column B, and C is A. Okay, perhaps I can show you how it's done. But let me show you the illustration. So this will be row of A for some row, one row of A, and this will be some row of some column of B. And this would be resulting in C. Okay, I think better we can use some example to give better illustration. So as long as our matrix, okay, for example, our matrix is 2, 2, and 2, 3. So for example, if we are looking at this 2 and 2 here, this is the same dimension, right? So the result will be 2, 3 when we multiply. And if we have 4, 3, 3, let's say 3, 2, we will have 4 and 2 when we multiply. The result will be 4, 4 and 2. But if we have different, and then 3, 2, this 2 and 3 is not the same, okay? So we cannot multiply this. Okay. Let me give you examples, and we are going to see some exceptions and how we are going to deal with the property of the multiplication. Okay, let's say the example. Let's say we have A is equal 1, 3, and 1 and 0, and B is equal 4. Okay, let's calculate AB. So AB, we can write down our matrix. Okay, and the idea here will be we are going to multiply this with this plus this and this. Okay, and we are going to have another one this and this and this and this. Okay, let me write all the possibility here. So let's see the size of the matrix. This is 2 by 2. This is 2 by 3. So the result should be 2 by 3. Okay, let's write down the results. So 2 by 3. Okay, so we will have 2 rows and 3 columns. Okay, let's do this. Okay. All right. So the first one here is from 1 multiplied by -1 plus 3 and 0. So it will be, okay, this, it will be -1. Okay. And the second, let me write this, -1 is 1, and 0, 0 is 0, so this will be 1. Maybe I will erase this. Okay. And same way, the second row or the second column, we will get from 1 multiplied by 5 is 5, plus 3 multiplied by 4 is 12, 12 plus 5 is 17. Okay, and the second row, second column, we will get -1, 5, 0, 4, 0, it's -5. And same way, we are getting the 21 plus 2 is 23 and -2 at the end. So we are going to have the product for the multiplication of AB is -1, 17, 23, 1, -5, -2. This is the product of AB. Okay, if we are looking for BA, okay, that's right, B. Okay, by looking at this size of the matrix, okay, this will be size 2, 3, and this is 2, 2. Okay, by the size, we check this 3 and 2. It's not matched, right? It's not matched, it's not equal. And when you try to solve, so the row and the column, it's not matched. So 1, 1, 5, 1, and what about 2? That's the problem. The problem in matrix. So for multiplications, AB is not the same as BA. We still may have, if we have this, we still have A, B, C, okay, we still have that. And if we still have we still have also that. And same way if we have this is also BA plus CA. And again, this AB and BA, it's not the same. Okay. This is a property of multiplication on matrices. So BA for this example is undefined, but if you have 2 by 2 for A and 2 by 2 for B, AB is still not the same as BA. The results will be different. Okay. I think I will stop here and we'll continue tomorrow, and I'll prepare some feedback for you to check. Okay. And hopefully you can evaluate some calculations. Okay, I hope you already write over here on the notes. Before we start the feedback, is there any questions? Okay, so we stop until the multiplication of matrices. Okay. Okay, there is no questions. So let me stop the presentation and give you the and hopefully the time is okay. I've already prepared the time for you guys. Please tell me feedback time. And start. Okay. How many we are now? Students. We have 8. Okay, we can start. 3, 2, 1, let's start. Okay, write in terms of x, y, z without no space. Okay, without space. Okay, so x, comma, y, comma, z. Then use the bracket. You can also remove the bracket. If you want. I already prepared this for the answer. Or you can write no solutions. Okay, not sure if the time is okay for you, but I hope it's okay. I hope it's okay. Time is too short, so I'm sorry. I will try again tomorrow. Longer time. Yeah, I think this should be 3 minutes. This is just to measure how fast you can evaluate this, and I can check how many of you are able to solve this. Okay, 3, 2, 1. Okay, everybody's skip the answer. Okay, got this. Yeah, I already write no space. Okay. Please listen to me. So no space, just comma. Okay, that's one. Okay, 3, 2, 1. Start. A similar question, but tried with a new system of equations. I think the time is okay. Maybe I will add few seconds next time. Maybe 2:30 or 2:40. Okay, 20 seconds left. We get the answer, right? Very good. Okay, last question. 3 to 1. So, I think I'm okay. Wait 5 seconds. Okay. Okay, it's started. Okay, so that will be the end of our lecture today. Dependence, I think I have showed you before, right? Okay, see you tomorrow.